So today we'll be doing the November 2021 Variant 1 Paper 1 Maths paper. So let's go. So first question, we just need to expand 1 minus 1 over 2x squared. So fairly nice question to start off with. So if I just do 1 over 2x and then have a bracket here, 1 minus 1 over 2x, well, then we know that we're going to get a 1, okay, because 1 times 1 is 1. And then we're going to get a minus 1 over 2x, and then another minus 1 over 2x, okay, so that'll be like a minus 2 over 2x, and then we get a minus 1 over 2x times by minus 1 over 2x, that gives us a positive 1 over a 4x squared, and then that simplifies down, so we get a 1 minus a 1 over x, and then plus a 1 over a 4x squared. And for the second question now, we need to find the first four terms in the expansion in ascending powers of x of 1 plus 2x to the power of 6, okay? So for this one, we can use normal binomial expansion, okay? So if something like 1 plus 2x to the 6, well, that is the same as we can do 6 choose 0, okay? And then that will be, now we don't need to include this, obviously we can just put 1, but I'm just going to write it like 1 to the power of 6, and then that is times by 2x to the power of 0, so that'll be the first term. And then for the second term, okay, it's going to be a 6 choose 1, and then that will be 1 to the 5, okay, again, don't need to put it, but I'm going to do it anyway, and that'll be 2x to the 1, and then we have a 6 choose 2, that will be 1 to the 4, and that will be a 2x squared, and then the first four terms, so last one, we get a 6 choose 3, and that'll be a 1 to the 3, and then that'll be a 2x to the power of 3. And now if we work this out, well, for this first one here, okay, 6 choose 0 is 1, times another 1, so we're left with a 1 for that first term. The second term, we have a 6 choose 1, which is a 6, times by a 2x, so that is a 12x. For that third term, a 6 choose 2. Now, what is a 6 choose 2? A 6 choose 2 is a 15, okay? So it's 15 times by a 2x squared. Well, 2x squared is a 4x squared. So 15 times a 4x squared is a 60x squared, okay? And then for that last one, we have a 6 choose 3. Well, 6 choose 3 is 20. And then we have that 2x to the power of 3, which is an 8x cubed. 20 times 8x cubed, that is a 160x cubed, okay? And yep, we've found the first four terms. We've got 1 plus 12x plus 60x squared plus 160x cubed. And now for the last bit, we need to find the coefficient of x in the expansion of the 1 minus 1 over 2x squared times by 1 plus 2x to the power of 6. So pretty much the two previous answers, we've got to figure out the coefficient of x. So I'm going to write the answers from the two previous questions. So for the 1 minus 1 over 2x squared, okay, that was 1 minus 1 over x plus a 1 over a 4x squared, okay? And that is being times by those first four terms of 1b, so that'll be a 1 plus a 12x, okay, plus a 60x squared, and then plus a 160x to the cube, okay? So effectively, we have all of this, and we need to figure out the coefficient of x. So what we can do is just look at terms from both brackets and see which ones will give us x, right, a coefficient of x. So if we start with this one here, okay, well, what can we multiply it by in this second bracket to give us an x coefficient? Well, this 12x, if we had to do a 1 plus 12x, that will give us an x coefficient. So the first maths we can do, or the first bit of working we can do, is we can do a 1 times by a 12x, okay? Now for the next value now, this minus 1 over x, well, which value will give us a x coefficient? Well, if it's a 1 over x, therefore, it will be the 60x squared, because the x would cancel out and we'll be left with just x, right? So our second calculation would be the minus 1 over x times by the 60x squared, okay? And then for another one, we look at the 1 over 4x squared. And again, what else can give us an x coefficient? Well, this 1 over 4x squared, along with this 160x squared, x cubed, that will also, the x's will cancel out, we'll be left with an x coefficient. So our last bit of workings will be the 1 over 4x squared, and that will be times by the 160x to the power 3. And now let's work all this out. So we get a 12x. And then for this one, it would be a minus 60x. And then for that last one, 160 divided by 4, that gives me a positive 40x. So we've got 12 minus 60 plus 40. Therefore, if we want to work out our x coefficient, what's 12? X minus 60 minus 40. So that would give me, so we get a minus 20 there, we get a minus 8x. Therefore, the coefficient of x is simply just going to be a minus 8. Question 2, we have this curve of equation y equals kx squared plus 2x minus k, and we have a line which is the equation y equals kx minus 2, where k is a constant. Find the set of values of k for which the curve and the line do not intersect. So again, when we have a question like this, when they do not intersect, this is talking about the discriminant, okay? So for a line when they don't intersect, we know that that means that b squared minus 4ac must be less than 0, okay? And that's effectively what we need to work out. So if they intersect, let's make these lines equal to each other, okay? So that will be a kx squared plus 2x minus k, and that is equal to a kx minus 2. And let's bring everything to the left side. So we have a kx squared plus a 2x. I'm bring that kx over, so now we get a minus kx, okay? And now I'll bring that 2 over, so we get a positive 2 minus k, and that's equal to 0. So now we've got everything on the same side. Now what we want to do is now I'm going to rewrite this slightly different. So we get a kx squared, and now I'm going to take out the factor of x. So we get a 2 minus k x, okay? And then we get a 2 minus k again, and I'll put this in brackets as well. The reason why I've put it in brackets is now we can easily see what our values are going to be, what our a, b, and c values are going to be. Because remember, for the b squared minus 4ac is less than 0, okay? That is when we have a quadratic, in the form of ax squared plus bx plus c. So now we can clearly see what our a, b, and c values are going to be. We know, looking at our quadratic now, okay, make this a bit bigger, we know that our a value is simply just going to be k. We know our b value would be a 2 minus k, and we know our c value would also be a 2 minus k. And now we can use discriminant b squared minus 4ac, and because it says the lines do not intersect, we make it less than 0. If it said the lines intersect at 2 distinct points, we'd make it greater than 0. And if it intersects at 1 point, it would be equal to 0. But because it does not intersect, we need to find the values of k where it does not intersect. So that's why we make it less than 0. So let's go about doing this then. So b squared minus 4ac. So that would be a 2 minus k squared, okay? That would be minus a 4 times a, so minus a 4k, and then times by c, which is a 2 minus k, okay, and that has to be less than 0. So a 2 minus k all squared, well, we'd get a 4 out of that. We'll get a 2 times a minus k, minus 2k, and then another minus 2k. So we get a minus 4k, and then we get a minus k times a minus k, which is a positive k squared. Then we get a minus 4k times 2, which is a minus 8k. And then a minus 4k times a minus k, that is a positive 4k squared. And that is less than 0. And now that means if we add our values together, we get a 5k squared. Minus 4k minus 8k is a minus 12k. And then we have a 4, or just that 4 then. So that's a positive 4. And that is less than 0. And now if we're looking about factorizing this, if we put it in brackets, okay, we get a 5k here and a k here. Now this one's a nice one because 5 is a prime number. we know that if we're to put it in brackets, one of them have to be a 5, the other has to be a k, a 5k and a k. So it makes brackets easy. And then for this one, we have a 4. So there's only really a certain amount of numbers it can be. We can either get 1 and 4 together, or we can get 2 in both. So that's really what we need to think of. Now we have this minus 12, so we know that it's gonna most likely have to be 2 negative values. So in this case, if we think about it, it would have to be a 2, okay? 5k minus 2 and k minus 2. Okay, now you don't need to do that. You can also put this into a calculator to work out your values as well, or there's also other ways you can figure out how to factorize it. But this one works, and then if you like to work it out, well, we get a 5k times a minus 2, which gives the minus 10k, and then a minus 2 times a k gives us the minus 2k, gives us the minus 12k. It all works out. But anyway, once we've factorized that, we've got these two values. Therefore, we know that k is equal to a 2 over 5, and k is also equal to a 2. So worked out those values, but we're not done yet, okay? Because now we need to remember it's less than 0. So we still need to figure out when this is going to be less than 0. So if I draw a little diagram over here, okay? So with my diagram, what do we know? Well, we know this is a quadratic equation. It will look something like, if it crosses that positive 2 over 5 and positive 2, therefore it's going to look something like this, okay? Let's just say it's like that. And then we know that this point here is 2 over 5. This will be a 2. And then we're saying that when it's less than 0, so it will be like this value here, because less than below the x-axis, okay? Therefore, we know that it's going to be 2 over 5 is less than k, which is less than 2. So what that means is any value between 2 over 5 and 2, these lines would not intersect, okay? K cannot be between 2 over 5 and 2. If k is between 2 over 5 and 2, then the lines just do not intersect. So for question 3, we have 6 cos theta tan theta minus 3 cos theta plus 4 tan theta minus 2 is equal to 0. We need to find out what theta is between 0 and 180. Now this is a bit more challenging, as we have to solve by factorizing, right? But the factorizing isn't as simple as maybe we would like, right? So what I would do in this type of question is, there's a way to factorize this, which if you know this, can help you out a lot with these type of questions. And you may have seen it before, just not in this form. But what we can do is, what I'm going to do is I'm going to split these up, okay? I'm going to draw a line down the middle here, okay? And I'm going to factorize these two separately, okay? So I'm going to factorize 6 cos theta tan theta minus 3 cos theta. I'm going to factorize that. And then I'm going to factorize the 4 tan theta minus 2. So let's do that. So if I do the 6 cos theta tan theta minus 3 cos theta, what do we get? Well, we can take a factor of 3 out, okay? And also a factor of cos theta. And then in the brackets, we would get a 2 tan theta, okay? And then we would get a minus 1. And then on the right side, I'm now going to factorize that separately as well. So we can take a factor of 2 out, okay? And then in the brackets, we would get a 2 tan theta minus 1. Now, would you look at that? When we factorize it separately, we get the same value inside the brackets, 2 tan theta minus 1. So what does that mean? Well, that means that we have 3 cos theta lots of 2 tan theta minus 1, and then we also have 2 lots of 2 tan theta minus 1, which means that we can just join them together. Therefore, this now becomes 3 cos theta plus 2, and then the other bracket would be 2 tan theta minus 1, okay? So we've actually factorized it now, and this would equal 0. And just like that, we've been able to factorize it, okay? So what you can do in these situations, if you're in a situation like this where it looks a bit challenging, try and split it in half and then factorize each of them separately. You may have seen this before when you factorize with quadratic, where the a value, right, is greater than 1. So if it's like a 3x squared or 4x squared plus something, you may have came across using this type of method before. But yeah, it's another method we can do. And now that we've factorized it, well, now we've done the factorizing part. Now we can look at solving it now. Okay? So therefore, if we start with the cos theta, that means that 3 cos theta plus 2 may equal 0, or we get a 2 tan theta minus 1. Okay, that may also equal 0. Therefore, therefore we have that a cos theta that equals a minus 2 over 3. Okay, and then we also get a tan theta that equals a half. And now if we draw 2 cast diagrams, okay, so I'm going to draw 2 cast diagrams, one for the cos theta and then one for the tan theta. So if I do that here, so that's the first one. Okay, and then let me just copy this for our second one. So this will be the tan theta. Okay, and then all stations towards Croydon. All stations towards Croydon. So on your calculator, if we look at the cos theta first, okay, is equal to minus 2 over 3. Now, if you do this in your calculator, you do the inverse of cos, okay? Actually, no, let's not even look at the inverse of it. Let's just do the normal cos of just positive 2 over 3, right? If you do it into your calculator, you will get a 48.2, okay? But remember, our cos value is negative, okay? Our cos value is negative. So what does that mean? That means that whatever value we get, okay, we know that we're going to be in these 2 quadrants here. We're going to be in these 2 quadrants in this case because cos is negative. So we're going to be in this sine quadrant and we're also going to be in this tan quadrant here, okay? So if you do the inverse of cos of positive 2 over 3, you will get 48.2. But in this case, because we're dealing with a negative value, that would be over here, okay? It would be 48.2 over here, and you'd also get 48.2 over here. Now, on your calculator, you could also do the inverse of cos of minus 2 over 3, and actually, if you did that, it would actually give you this value exactly, which we'll get onto in a minute. But I think it's always best to do the positive value because I think it just is better to do that value because then that tells you all your other possible values as well. And for the tan theta, okay, if we do tan theta, it's positive. So because tan theta is positive, okay, we know that we're going to be in this region here, and we're going to be in this region here. So if you do the inverse of tan of a half on your calculator, you will get to 1 decimal place, you will get a 26.6, okay? So we do a 26.6 there and another 26.6 here. And now in the question, okay, it wants values between and including 0 and 180. So now we just need to look at what we've got, okay? And then look at what values do we have between 0 and 180. So if we start with a cos, well, it would just be this value here, okay? Because that value is before 180. It's all values before this point here. So right now it would just be this value. So what would that be? That would be 180 minus a 48.2. So if you do 180 minus a 48.2, that will give us a 131.8. And then that's it for that one. And then for the tan one, if we do the same thing, it would just be to this value here because this other value here that's past 180, so we don't include it. So we just include this value here, which is simply 26.6, okay? And that would be our answer, 26.6 degrees and 131.8 degrees. And also, if you use your calculator, and let's go back to the cos theta, if you did cos theta, the inverse of cos of minus 2 over 3, you should get the 131.8 degrees as well. So for question 4, we have the first term of an arithmetic progression is a, and the common difference is minus 4. The first term of a geometric progression is 5a, and the common ratio is 1 over 4. The sum to infinity of the geometric progression is equal to the sum of the first 8 terms of the arithmetic progression. Find the value of a. Okay, so there's a lot to unpack here. So let's start by writing down some things for the arithmetic progression, okay? We know that the first term is a. So we know that a1 is just simply a, okay? We're told the common difference is minus 4, so we know that D is minus 4. So we know that's the arithmetic progression, okay? Now we know the geometric progression, okay, we know the first term of that is 5a. So I'm going to write that as capital A1. We know that is a 5a. And we know the common ratio, so we know our value is a minus 1 over 4. Okay, so just written down some values. Now we're told the sum to infinity of the geometric progression is equal to the sum of the first 8 terms of the arithmetic. So let's try and work out the sum to infinity of the geometric progression. So for that, that would be the sum to infinity, that would be capital A1 over A1 minus R, okay? And if we work this out, well, we know A1 is a 5A, and we know that will be over 1 minus a quarter, so that's 1 plus a quarter, and then if we work this out, we get a 5A over 5 over 4, okay? And then if you work this out, you will be left with a 4A, because your 5s would cancel out. So we know that the sum to infinity for the geometric sequence is a 4a, and therefore we know that, and we also know that's equal to the sum of the first 8 terms of the arithmetic. So now let's look at the sum of the first 8 terms of the arithmetic, okay? So for the arithmetic one, we know that the sum of an arithmetic is n over 2 times by 2a1 plus n minus 1 d, okay? So in our case, that'll be S8 is equal to 8 over 2, which is a 4. 2 times A1, well, for the arithmetic, A1 is just A. So that would just be a 2A plus 8 minus 1, so that's a 7. And what was our D value? Our D value was a minus 4 here. So it's just going to be times by a minus 4. Okay. So that would be a 4 2a minus 28, okay? And then that would give us an 8a minus 112. Let me different color for this. So that would be a 8a minus 112. So now we've actually worked out the sum to infinity of the geometric progression, okay? That was just a 4a. And the sum of the first 8 terms of the arithmetic progression was an 8a minus 112. They tell us in the question that the sum to infinity is equal to the sum of the first 8 terms. Therefore, we know that the 4a must equal the 8a minus 112. And then, yeah, we can now rearrange this. So let's bring that 8a to the other side. So we get a minus 4a is equal to a minus 112. Therefore, our a value is just going to be minus 112 divided by 4, which is simply going to be a 28. For part B, okay, we have that the kth term of the arithmetic progression is 0. Find the value of k. So to find the value of k, well, if it's the kth term, the equation for that would be ak is equal to a1, okay, plus k minus 1d, okay? That's the equation for finding a term. Now, in our case, what would that look like? Well, that would be AK, okay, is equal to, we know A1 is just A, plus a K minus 1, and D was a minus 4, so we know that it's going to be K minus 1 times by a minus 4. And in the previous question, we worked out what A was. We worked out that A was just simply going to be a 28, so therefore, we know that it's an AK is equal to a 28, and then that would be a K times a minus 4 is going to be a minus 4K, and then a minus 1 times a minus 4 is a positive 4. So you know AK is equal to a 32 minus a 4K, and they tell us that the kth term of this arithmetic progression is 0. So we know that for this kth term, it's 0. Therefore, 0 must equal 32 minus 4k. Therefore, 4k is equal to 32, or not 38, 32. Therefore, our k value is simply 8. So for this question, okay, we have part of the graph of y equals a cos bx plus c, we need to find the values of the positive integers a, b, and c. So how can we go about this? So what I've done is I've just drawn a rough sketch of y equals cos x, right? And as you can see, this is a graph of y equals cos x. Now from 0 to 2 pi, as you can see, if we look at the shape of it, it looks fairly similar, but as you can see, right now where we have the where x equals to pi, okay, in our transformation, it's at the top here. So something's happened there. But then if you look, the 2x value is still the same. The 2 pi value is still the same. So what's happened? Well, actually what's happened is it's like oscillating like 2 times as much within that zone, right? Because as you can see, we have like 2 kind of troughs or peaks, how you want to look at it, right? In our one, we just have one, right? We just have like 1 point like this. But in our graph, we have something like this. So it's like oscillating twice as much. Therefore, just on that note, we know that our b value is 2 because it's going twice as much in that same zone. It's hitting twice as many points in that same zone. So already we know that it's the b value is 2, okay? So if we know our b value is 2, that means that now let's draw a graph of y equals cos 2x. So now I've drawn the graph of y equals cos 2x, okay? So now it's taken the shape. It looks very similar now. But as you can see, it should be a 1 here. Okay, as you can see, if this is 1 and down here is a -1, in our graph that they've given us, right? Well, we've got an 8 here, so the maximum is an 8 and the minimum is a -2, okay? So we now know that they've definitely stretched it by a scale factor in the y direction and they've shifted it either up or down, right? Now that's all we need to figure out now. So how can we figure that out? Well, what you want to think of is if you look at 8 and -2, okay? Now 8 and -2, that is a difference of 10, right? That's a difference of 10. So we know that in our y values, right, there has to be a difference of 10. So right now, in our one here, y equals cos 2x, we only have a difference of 2, right? We have 1 and -1. That's a difference of 2. But we know that we need a difference of 10. So what can we do to go from a difference of 2 to a difference of 10? Well, we can just multiply by 5. So therefore, we know that we're going to multiply by 5. So now we're going to be at y equals 5 cos 2x. And if we multiply by 5, so if we do 5 cos 2x, right, that means we're going to stretch in the y direction of 5, which all that would change for our diagram purposes, we can keep our diagram the same and we can just change these y values. So now these y values our maximum now will be 5 and our minimum will be -5, and this will now change to y equals 5 cos 2x. Okay, let me just make that look a bit better. Y equals 5 cos 2x. So now we've got y equals 5 cos 2x, okay? And now we've got that difference of 10 now in the y direction. Now it's fairly simple to know what you need to do now to get it to 8 and to -2. If we just shift everything up by 3 units, right, that 5 will then change to 8, and that -3 will also then change to 2. So if we just shift everything up by 3 units, well then that 5 will then change to an 8, and then this will be a -2. And yeah, that's exactly what we want. That's transformation. Therefore, we know that for question A, okay, we know that it would just be 5 cos 2x plus 3, okay, where A is 5, B is 2, and C is 3. So for part B now, okay, we need to determine the number of solutions between 0 and 2 pi for each of the following equations. So the first one is a cos bx plus c is equal to 6 over pi x. So remember that a cos bx plus c that's the diagram, like that's the graph we've already got. And we have this 6 over pi x. So really, we need to just draw that straight line onto the graph, okay, and see how many points of intersection there is. So if we start with that one, the y equals 6 over pi x, okay? Then for y equals 6 over pi x, well, we want to think of coordinates. So let's think of 2 coordinates for it, and then just join them up and see how many points it hits. So the easy one we can do is the origin, right? We know that 0, 0 is going to go through the origin, right? So we know 0, 0, that's a coordinate on that point of y equals 6 over pi x. And now you want to do another one which is going to be easy for you to solve. So an easy one would be to look at what coordinates you have, right? So we have pi, right, as an x value. Well, if we make x pi, then we get 6 pi over pi. That makes y 6. So we know that pi 6, that's another coordinate. And that'll be easy to plot on our graph. So now let's look at my graph and let's just plot those values. So we know that 0, 0, that's a point, and we know pi over 6. So we look where pi is and we look where 6 is. That would be this one right here, okay? And now all we need to do is just join up those two lines. So if we join up these two lines, okay? Now, hopefully my thing will straighten out. Yep, like, oh, why is it not going? Go in the middle there. Okay, well, effectively, it doesn't want to go in the middle. But as you can see, effectively, let's just say all of this like that. Okay, cool. So now we've drawn this straight line now. And this is y equals 6 over pi x. Now we just need to look at how many points of intersection does it have. Well, it intersects here, and it intersects here, okay? So that is 3 points of intersection. Therefore, it has 3 points of intersection. Therefore, for that question, it would have 3 solutions, okay? So that's BI done. And then for the second question, okay, we have to do 6 minus 6 over pi x. So for that second part, if I just erase all of this now. So for that second part, we now have y is equal to a 6 minus a 6 over pi x. And again, we just do a similar thing, So pick two coordinates. Well, for this one, we can't actually use, we can't use 0, 0 because this one won't go through the origin, but we can still make x 0. Because if we make x 0, we're left with just 6. So we know that 0, 6 is a solution, okay? And then for another point, again, use pi or 2 pi, use something which will be easy for you to solve later. So if we use x when x equal to pi again, we get that 6 pi over pi, which will give us a 6, and then a 6 minus 6 gives us a 0. So we know pi 0, that is also going to be a solution. And then again, we do the exact same thing, okay? We just find those 2 points. So 0, 6 is here, and pi 0 is here. And then again, we do the same thing. Now, if I just draw these two lines here, okay, see if I can get it exactly, that will do. So now we've got these two here, and again, we just look at the points of intersection with the curve. So it intersects here, and it nearly intersects at 2 pi, but as you can see, it just about misses 2 pi. So just be very careful with your accuracy. Obviously, I'm doing it on this, so I guess I can make it accurate, but just make sure you use a ruler. Yeah, just so you don't accidentally include like this point here, and then you say 3. But yeah, as you can see, intersects at 2 points, intersects here, and intersects here. Therefore, for this one, it would simply just be 2 solutions. For question 6, okay, we have this diagram. It has this odd shape here. It has this metal plate ABC in which the sides are the straight line AB and the arcs AC and BC. The line AB has length 6 centimeters. The arc AC is part of a circle with center B and radius 6 centimeters. And the arc BC is part of a circle with center A and radius 6 centimeters. Find the perimeter of the plate, giving our answers in terms of pi. Okay, so for this one here, we just find the perimeter. So that means, and also find the perimeter, we need to find these arc lengths here, okay? We need to find what these arc lengths are. Now, lucky for us, they are going to be the exact same length, but it may not be easy to figure out first what we need to do to work them out. But what we do know is if we look at the arc BC, for example, we know the arc BC has center A. They tell us that in the question. We know that this has BC, okay? So if I was to draw a line from this to this point here, okay? We actually know that because that's the arc that's on the arc BC, it has center A. Well, we know at center A, it says that has radius 6 as well. So we actually know that this line here is 6 centimeters, okay? We know that that is 6 centimeters. And what do we know? Well, if we do the same thing, but we do it for AC, okay, we know that AC has the center B and radius 6. So we get to do the same thing from AC to B. We know that this is also going to be a 6 centimeters. That's what they tell us in the question. And then, would you know, if you look at the straight line AB, it also has 6 centimeters. So all of our angles, all of our sides equal 6 centimeters, which means that we have an equilateral triangle. I probably said that wrong. An equilateral triangle, okay? So what does that mean? If we have an equilateral triangle, then we know that all our angles must equal, in this case, pi over 3, because we're dealing with radians, okay? So it'll be 60 degrees or pi over 3. And because we know that, we now know the angles, this actually becomes a very simple question, okay? Because now, effectively what we can do is we can actually just work out the arc length, okay? Of any of either BC or AC, doesn't make a difference. And we can now work out the arc length is. So now that we know it's an equilateral triangle, we know that all of these angles are going to be pi over 3. If I just erase this and let's just do one of these lines now, so it's a bit more simple looking at it, right? Then we know that this here is a pi over 3, okay? And yeah, and we know that the radius is 6 because that's what they tell us in the question. Well, now we can actually work out what this arc length is, okay? Because it's just going to be arc length is r times theta. Well, we know r is 6. We know the angle now is pi over 3. So it's just 6 times pi over 3, which therefore gives us 2 pi. So we know the arc length now. We know that this arc length is just going to have a 2 pi as its length, and they are symmetrical. So AC would also have a length of 2 pi. Therefore, if we want to work out what the perimeter is, it's going to be 2 pi plus a 2 pi plus a 6. Therefore, our answer would just be a 6 plus a 4 pi. And for that second question, we need to find the area of the plate, giving our answer in terms of pi and root 3. So let's work out the area first, okay? So to work out this question, we've worked out the whole area of the plate. Then the way I'm going to do it is I am going to work out the area of this arc here. And then once I work out the area, I'm also going to work out the area of this segment here, okay? So let's look at the area of the arc first. Well, we know the area of an arc is just a half r squared theta. An arc waist, that will be a half times a 6 squared times a pi over 3, which will give me a 36 times a half, so that's an 18 times a pi over 3, that'll give me a 6 pi. So the area of the arc is 6 pi. Now we need to look at the area of the segment. Now, there's actually a formula for the area of a segment. To look at the area of a segment, the formula is a half r squared theta minus a sine theta, okay? And we can use that to work out the area of this segment here, okay? We have all the information we need, okay? Because we have the radius bit. We know that it's still going to be a 6, okay? And we have the theta. We can just work that out. In this question, it will be a half times by 6 squared, okay? And then that will be a pi over 3 minus a sine pi over 3. So therefore, we end up with 18, and then in brackets, a pi over 3 minus sine pi over 3. Well, what is a minus sine pi over 3? Well, a minus sine pi over 3, again, doing a calculator, or you may have known it already, that is just going to be a root 3 over 2. So therefore, 18, if we make this all over a single fraction, okay, let's make it over 6, okay? then we'd get a 2 pi over 6 minus a 3 root 3 over 6, okay? And if I just do this on the other page now, so now we're at this stage, so that would be an 18, and then in brackets we have a 2 pi minus a 3 root 3, and that is all over 6, okay? And now if we look at simplifying this down now, well, the 18 and the 6 will cancel out. This will be a 3, this will be a 1. So therefore we're left with a 3, 2 pi minus a 3 root 3. And then this would equal a 6 pi minus a 9 root 3, okay? So now we look at the area of the segment, okay? This is the area of the segment, okay? Area of the segment is simply just a 6 pi minus a 9 root 3, okay? And we know that the area of the arc, as we also worked out, we know that that was just a 6 pi, okay? We know that the area of the arc was just a 6 pi. So going back to it again, we just to reiterate, we know that the area of this arc here, we know the area of this arc is just 6 pi. And we know the area of this segment here is 6 pi minus 9 root 3. Therefore, if we want to work out the area, just need to add them up together, okay? So if we add these up together now, we get a 6 pi plus a 6 pi minus a 9 root 3. Therefore, we get a 12 pi minus a 9 root 3. So for question 7, we have a circle with center 5, 2 passes through the point 7, 5. Find an equation for this circle. So all we need to do really is just look at the radius, okay? So let's just work out the radius. And to do that, we just need to use Pythagoras' theorem. So if we think about it, let me just draw a circle quickly. We got a circle here. We are told that it has center 5, 2. So we know that this point here is 5, 2. And it passes through the point 7, 5. So let's say 7, 5 is here. Therefore, we need to work out what the radius is, which we can do using Pythagoras' theorem. So fairly simple, because we know that there'll be like if we look at a right angled triangle here, okay, we can just use we can work that out. So if we do that now, what would that look like? Well, the difference in, let me just draw the triangle here, okay? So and we know that this is a 5, 2 and this is a 7, 5. Well, let's look at the difference in the x direction, okay? Well, we have a 5 and a 7, so we know that it's a difference of 2. And in the y direction, we have 2 and a 5, difference of 5. So therefore, it would just be a 2 squared plus a 3 squared. And that gives me a root 13, okay? To know that the radius is a root 13, okay? We know that the radius here is a root 13. So now if we think about writing this in the equation of a circle form, that is x minus a squared plus a y minus b squared, that's equal to r squared. Therefore, we know the center is 5, 2, they tell us in the question. So it's just x minus 5 squared plus a y minus a 2 squared. And if r is root 13, r squared is simply just 13. And that would be the equation of the circle. So for part B, we have the line y equals 5x minus 10. It intersects the circle at A and B. We need to find the exact length of the chord AB. So what that means is effectively all we need to do is find out where that line of y equals 5x minus 10, where it hits the circle, okay? And where the 2 points intersect the circle at, then again we need to find the length. So to find out where it intersects the circle, well, it will just simply be just use simultaneous equations here. So again, if I just rewrite what we had, okay, we had, what was it? It was an x minus a 5 squared plus a y minus a 2 squared, okay, and that was equal to 13. And we also have right over here that y is equal to 5x minus a 10. So again, if we just plug the y equals 5x minus 10 into the circle equation, and then just expand out the brackets, we should be able to get values for x and y, find our coordinates. So if we do that, we get a x minus 5 squared, and then we would get a plus a 5x minus 10 minus 2. That's a 5x minus a 12 squared, okay, and that's equal to a 13. And then we just expand the brackets out. So we get an x squared plus minus a 10x plus a 25. And then for this one, we would get a plus 25x squared. 5x times a minus 12 is a minus 60x, and then another minus 60x. We get a minus 120x, and then we get a positive 144, and that's equal to 13, okay? And now we group all values together, so we get a 26x squared, okay? A minus 10x minus 120, so that's a minus 130x. Then we have a 25 plus a 144, which is a 169. We also have that 13. I'm going to bring that 13 to the other side, so it's a 169 minus 13. So that's a positive 156. And that is equal to 0. And now we're at this stage. Lucky for us, all of these values actually divide by 26. Okay, they all go into 26. So if we divide everything by 26, you're left with an x squared minus a 5x plus a 6. And that's equal to 0. And now we can just solve what this is. If we factorize this, we get an x minus 3, x minus 2. That's equal to 0. Therefore, x is either going to be a 2 or x is going to be a 3. So we get x is equal to 2 and x is equal to 3. We're not done yet. That's our y values. Let's look at that's our x values. Let's look at our y values now, and that will give us our coordinates. So to work that out, we need to put it into one of these equations. I will choose y equals 5x minus 10 because that is the easier equation to use. So if we put both these values in, well, if we have a y equals a 5x minus 10, then when x is equal to 2, that will be y is equal to 5 times 2 minus 10, which makes y 0. So we know that the coordinate, one of the coordinates is just a 2, 0. And then when x is equal to 3, we do the same thing. We get y is equal to a 5 times 3 minus 10. Y would be a 5. Therefore, our other coordinates would be a 3, 5. Okay, so now we've worked out our coordinates. We know that where that line hits the circle. So now what I'm going to do is, on my diagram here, what I'm going to do is I'm going to draw these 2 points on. So if it's 2, 0 and 3, 5, then let's say that 2, 0, a rough estimate it would probably be maybe like here, for example. And if it's a 3, 5, it will probably be, let's say here, okay? So if we then draw this line, okay, that is the chord, okay? So this is 2, 0 here, and this is a 3, 5 here. And yeah, this would be the chord, and we need to figure out the length, okay? And again, like in the previous question, it's just the length is like Pythagoras' theorem, okay? Right angle triangle here. And then we can figure out the length. Okay, so if I do that here, like this, then we have this right angle triangle here. This is supposed to be a right angle triangle. That would have a 2, 0 at this point here. Would have a 3, 5 here. So let's look at the x direction first. Well, it's change in x is 1, and for the y, it's a 5. Therefore, it's going to be a 5 squared plus a 1 squared, all square rooted. And that gives us the length of root of 26. Therefore, the length of the chord is just the square root of 26. So for question 8a, okay, we've got to express minus 3x squared plus 12x plus 2 in the form of minus 3x minus a all squared plus b, where a and b are constants. So for this question, we just need to complete the square, okay? Fairly nice question. So if we take out the factor of minus 3, that will leave us with an x squared. Then we get a minus 4x. Remember to make your signs the right way. And then we get a minus 2 over 3, okay? And now we need to complete the square on this. So that will be a minus 3. I'll use this brackets here. That would be an x minus 2 squared, okay? And then we have to minus a 4 from that. And we also have that minus 2 over 3. Like this. So therefore, and then in brackets, x minus 2 squared. Minus 4 minus 2 over 3, what is that? Well, if you might write minus 4 as a fraction, okay, that would be minus 12 over 3. So it's minus 12 over 3 minus a 2 over 3. That would be giving me a minus 14 over 3. And now what we can do is we can actually times everything by that minus 3. Now, if we times what's in the x minus 2 squared, we can leave that as a minus 3, and then in brackets x minus 2 squared, okay? And then we have a minus 3 times by a minus 14 over 3. That just leaves us with a positive 14. So therefore, answer is a minus 3 x minus 2 squared plus 14. So for part B, we have that the one-to-one function f is defined by f of x equal to the minus 3x squared plus 12x plus 2 for when x is less than or equal to k. State the largest possible value of the constant k. So this can seem like a weird question, right? But what they're saying is if it's a one-to-one function, well, we know that with a quadratic equation, okay, it's usually going to be a 2-to-1 function, right? Because you're always going to have two sets of x values corresponding with a y value, right? For example, like you could have like minus 3 squared is 9, 3 squared is 9. That's a 2-to-1, okay? You have two x values corresponding with the same y value. In this case, if it's 1-to-1, then effectively what that means is actually only going to be half of the function. So in this case, if we have this quadratic equation now, it's a negative, so it's going to be in an N shape. Effectively, it's going to be something like this, okay? So for minus 3x squared plus 12x plus 2, it's going to have this type of shape, okay? And then whoop, and we're going to stop. We're going to stop. Now, why are we stopping? Because it's a one-to-one function, which means that we can't have two values. We can't have two x values corresponding with the same y value. So actually, we actually stop here. We stop at that point. And because we stop at that point, well, we want to find the largest possible value of the constant k. So effectively, what is the largest possible value of x? And to work out the largest possible value of x, well, we know that the largest possible value, even if this was a normal quadratic equation, the largest value would just be whatever the stationary point is, right? So we need to look at the stationary point. And to do that, well, it's fairly easy. That's just dy, or in this case, f dash x is equal to 0, okay? So we can differentiate equal 0, and that will give us our k value or our x, or our largest x value, okay? Either one. So if we differentiate this, well, f dash x, that would be a minus 6x plus 12. And we know that that must mean that 0 is equal to minus 6x plus 12. Therefore, 6x is equal to 12. Therefore, our x is equal to 2, which therefore means that our k value is 2. Okay, so we know that this value here has an x coordinate of 2. Okay, so that's all it means. Pretty much, you just need to find out the pretty much just the stationary point. Okay. Now for the next question, we're told that given that k is equal to minus 1, state the range of f, okay? So if I again draw a diagram, well, if we know k is equal to minus 1, what does that tell us? That tells us that our x value is equal to minus 1, which means that our largest possible x value is minus 1. So if we say, let's say minus 1 is, let's say this point here is minus 1, then what we're saying is if we draw the same graph, we're going to go, and we're going to stop. We are going to stop right there because we know the largest possible value of x is minus 1. So we're just going to stop right there. And now we look at the range of this, okay? So how can we work out the range of this? Well, if we can figure out what the point is here, okay, that like the y value, well, that will help us figure it out. Because if we know what the y value is there, we know that it can never be bigger than that y value, so it'll be all values less. So to work that out, well, we know the equation is just the equation is just going to be a minus 3x squared, okay, and then it was plus a 12x plus a 2, okay, we know that that was f of x, so therefore just need to do f of minus 1. F of minus 1, that would be a minus 3, minus 1 squared plus 12, minus 1 plus 2, so that will give me a minus 3 minus 12 plus 2, which gives me a minus 13. So therefore, we know that the coordinate here is minus 1, minus 13. If we want the range, well, the range of this would just be, for the y's, it would be all values less than minus 13, right? Because you can see it's going to go down, it's going to go towards infinity, but it will never be bigger than minus 13 for the range. Therefore, the range would simply just be f of x, okay, is going to be less than or equal to a minus 13. And for part D, we need to find an expression for the inverse of x, inverse of f of x, right? So f to the minus 1x, okay? So if we do that, well, first things first, let's write out what we had initially. So we had y is equal to a minus 3x squared plus 12x plus 2, okay? That's what we had initially. And we also know from when we factorized, okay, when we complete the square, that this is the same as y equals minus 3x minus 2 squared plus 14. We also know that as well. So if we look at the inverse of this, well, what we can do is we can replace our x and y values. So it becomes x is equal to minus 3, y minus 2 squared plus 14. And now we can rearrange for y, and that will give us the inverse. So if we do this, therefore, we would get a x minus 14 is equal to a minus 3 y minus 2 squared. Then we can divide by the minus 3, so we get a minus x minus 14 over a 3, okay? And that's equal to a y minus a 2 squared. I'm going to rewrite this now. To get rid of that negative, let's just multiply by minus 1. So therefore, we get a minus x plus a 14. So therefore, I'm going to write this as a 14 minus x over 3. And that's equal to a y minus 2 squared. Okay, now at this stage, we can now get rid of the square root. So we get a, let's change direction. So we get a y minus a 2. That's equal to plus or minus the square root of a 14 minus x over 3. Therefore, we have that y is equal to a 2 plus or minus the square root of 14 minus x over 3, okay? So now that we've got what the expression is, we're not actually done yet. You got to be really careful with these types of questions. They love putting these types of questions in where you get a plus or minus, but actually only one of those is the correct solution. So going back to the previous question, okay, for part C, we have that is now given that k is equal to minus 1. Now, what does that mean? That means that for f of x, okay, that means that when we were dealing with f of x before, we actually know that the domain, okay, the domain of this, the domain was when x is actually less than or equal to 1, okay, because they tell us that given that k is equal to minus 1, we know that the domain for f of x is when x is less than or equal to minus 1, okay? Now remember, when we're dealing with inverses, it's just going to be the opposite, okay? If we know that for, if I write it here, if we know that for f of x, we know that the domain is x is less than or equal to minus 1. We know that for the inverse, okay, the inverse, we know that the range, let's say y, or f of x, has to be less than or equal to a minus 1, okay? Remember, the domain of f of x is the same as the range of the inverse of f of x, and the range of f of x is the same as the domain of the inverse. So because we know that for a range, our y has to be less than or equal to a minus 1, well, if we look at ours here, we have a 2 plus or minus the square root of 14 minus x over 3. Now, if we have a 2 plus the square root of 14 minus x over 3, remember that the square root is always going to be a positive value. So if we have 2 plus the square root of something, that's always going to return a positive value. The only way we can get a negative value is if it's a 2 minus, because we want y to be less than or equal to minus 1. Therefore, by that logic, this has to just be y is equal to a 2 minus the square root of a 14 minus x over 3. Because we know the range has to be less than or equal to minus 1, that means our y value has to be less than or equal to minus 1. The only way to get that is if y is equal to 2 minus the square root of a 14 minus x, which is less than 3. That is the only way we can return a negative value, okay? Therefore, it's just y is equal to 2 minus the square root of 14 minus x over 3. It's the only way we can return a negative value. Okay, and for part E now, we have that the result of translating the graph of y equals f of x by minus 3, 1 is the graph of y equals g of x. Express g of x in the form of px squared plus qx plus r, where p, q, and r are constants, okay? So if we write out what f of x was, so remember f of x was the minus 3x squared plus a 12x plus a 2. And when we complete the square, that became a minus 3, and then in brackets x minus 2 squared plus 14. Now this is important why we write it in this form, because this makes it a lot easier now to figure out the translation. So if we start, let's start with the x value, okay? So we've got that it is, so it's transformed by minus 3, right? Now that minus 3, when it's written in this form, that means that it's shifted to the left by 3 units, shifted to the left by 3 units. So what does that do to the x value here? Well, what that becomes, okay, if I start writing g of x, okay, that would be a minus 3, and if we shift to the left by 3 units, then we need to plus 3 to this minus 2, okay? Because right now this is minus 2. We need to plus 3 to that, because that would effectively mean that would mean that we're going to shift to the left by 3 units. Okay, so remember, you got to be careful of this one because it feels counterintuitive. But when we're dealing with left and right, if we are shifting to the right, we want to minus it from the x. If we're shifting to the left, we want to plus to the x. Okay, in this case, we're shifting to the left, we're going to plus 3 to that minus 2. So it becomes x plus 1 squared. And then for the next one now, it's shift up by 1 unit. Okay, it's shifted up by 1 unit. So again, that 14, we need to plus 1 to that 14. So that would just be a plus 15. Okay, and now, could we want to write it in the form of px squared plus qx plus r? Just need to just expand the brackets out and then simplify down. So if we do that, we get a minus 3 in brackets, we get an x squared plus 2x plus 1 plus 15, which will give me a minus 3x squared. That will give me a minus 6x minus a 3 plus a 15. Therefore, our answer would simply just be, so g of x would be a minus 3x squared minus a 6x plus a 12. So for question 9, we have that the curve has equation y equals f of x, and it is given that f dash x equal to 2x squared minus 7 minus 4 of x squared. Given that f of 1 is equal to minus a third, find f of x. Okay, so pretty nice question. Just need to integrate and then put in our values of x and y to work out our constant, and yeah, we're done. So this question here, I'm just going to rewrite the f dash x as a 2x squared minus 7 minus a 4x to the minus 2. And we need to integrate this, okay? So if we integrate this, we get f of x is equal to a 2x to the power of 3 over 3 minus a 7x. And then this one would be a minus 4x to the minus 1 over a minus 1. And then we have the plus c. And if we simplify this down a bit, okay, we would get a f dash x is equal to a 2x to the 3 over 3 minus a 7x. And then for that one here, that would be plus a 4x to the minus 1 plus c, okay? And now they tell us in the question that f of 1 is equal to minus a third. So where we have x equal to 1, f of x is equal to minus a third. Now we can put in these values to work out our c. So therefore we have minus a third, and that is equal to a 2 times a 1 cubed over 3 is 2 over 3. That will give us a minus 7. And for this one, well, it's just 1, so it would just be a 4 plus c. And therefore, if we bring that minus 2 over 3 to the side, we get a minus 3 over 3. So that would be a minus 1 is equal to a minus 3 plus c. So therefore, we get c as being 2. And if we know c is 2, now we can rewrite this. We know that an f dash x, okay, that is going to be a 2x to the power of 3 over a 3 minus a 7x plus, and we rewrite it as 4 over x now. And then we also have a plus 2, okay? And that is f of x, okay? Done. So for part B, we need to find the coordinates of the stationary points on the curve. So again, to work out the stationary points, that would just be where f dash x is equal to 0. So go back to our question, okay? Well, we know that f dash x was 2x squared, okay? Minus 7 minus the 4 over x squared, okay? That was what f dash x is. So let's make that equal to 0, and let's just work out what x is. So what I'm doing first is I'm times everything by x squared. So we get a 2x to the power of 4 minus a 7x squared minus a 4. And that is equal to 0. Now I'm just going to apply a substitution. So let's let y equal x squared, okay? Therefore, we have a 2y squared minus 7y minus 4 is equal to 0. Becomes just a bit easier to factorize, okay? If you do this into your calculator, okay, what do you get for your y values? You get y is equal to a 4, and you get y is equal to a minus half. Therefore, what does that mean? That means that x squared is equal to 4, and we get an x squared is equal to a minus a half. If we work out what x value is now, well, just quickly, where the x squared is equal to minus a half, we can't do that actually, because obviously we can't square root a negative, so this just goes. And then for our next one, that would simply just be x. It will change my thickness. That will just be x is equal to a plus or minus 2. So we have our x values now, the stationary point is plus or minus 2. If we work that out, well, now we need to put that into whatever our f of x is. And remember, we worked out our f of x in the previous question. So let me just write what f of x was. Our f of x, that was the 2x to the power of 3 over 3 minus the 7x, okay, minus or plus the 4 over x plus 2. So now we're at the stationary points, you just need to put in positive 2 and negative 2. So if you redo that, let's do f of 2. F of 2, what would that give us? Okay. Now f of 2, if you work all this out, okay, I'm just to save time, I'm not going to go through the workings, but feel free to put this into your calculator. If you put 2 into x, then you would get a minus 14 over 3. Okay. And then for f of minus 2, so if you put minus 2 into your x value now for f of x, you get a 26 over 3, okay? So therefore, our coordinates would be, it'll be a 2 and then a minus 14 over 3. And we get a minus 2 and a 26 over 3, okay? So part C now, we just need to work out f dash dash x. So again, we just need to differentiate for a second time. So if we have f dash x, we know f dash x, okay, we know that was equal to a 2x squared minus 7 minus a 4x to the minus 2. If we differentiate that again, what do we get? Well, we would get an f dash dash x. Differentiating that again, that would give me a 4x. The minus 7 would go, and we would get a positive 8x to the minus 3. And yeah, that's f dash dash x. And for part D now, we determine the nature of the stationary point. So when they say the nature, they pretty much want us to figure out if that stationary point is going to be a maximum point or a minimum point, okay? And to work that out, well, effectively, if f dash dash x, okay, if our value is less than 0, when we put in the value of the stationary point, if it's less than 0, it would be considered a maximum point. It's a maximum point, okay? And if f dash dash x is greater than 0 at that stationary point, therefore it would be considered a minimum point, okay? So that's all we need to do. So let's start with the minus 2 first. If we start with the minus 2, if you do f dash dash of minus 2, well, what do you get? Well, you would get a, remember that f dash x is this value here. It's 4x plus 8x to the minus 3. So therefore, you would get a 4 times a minus 2, okay, plus, and in this case, I'm going to write it as 8 over x squared, okay? So it'll be 8 over a minus 2 to the 3, okay? And if we work this out, we get a minus 8, and therefore we get a minus 1, okay? Because we get a minus 8, 8, yeah, 8 minus a 1, there we go. So we get a minus 8 minus a 1, and that gives us a minus 9. But because we get a minus 9, okay, well, that is less than 0, okay? At that stage point, that's less than 0. So what do we know? Well, we know that this must be a maximum point, okay? And then we do the same for at the other stationary point, so f dash dash 2. So that would be a 4 times 2 plus an 8, okay? And that would be over 2 cubed, which would give me a 8 plus a 1, which is a 9. And then, so therefore, because that 9, that's greater than 0, that would be a minimum point, okay? So if I just clarify that, we know that f dash minus 2, or we can say at x is equal to minus 2, it is that was a maximum, so it is a maximum, and at x is equal to 2, it is a minimum, okay, right, something like that, and yeah, you're done. Okay, so for 10a, we need to integrate between the limits of infinity and 1 of 1 over 3x minus 2 to the power of 3 over 2 with respect to x, okay? So how can we go about doing this question? Well, first thing first, let's just treat it like normal, okay? So we have the interval of a infinity to 1, and I'm going to bring the 3x minus 2 to the top, so we get a 3x minus a 2 to the power of a minus 3 over 2, and we need to integrate that with respect to x. Okay, so let's go about integrating this. So if we want to integrate this, then how can we go about integrating something like this? Well, first thing we can do is we've got this 3x minus 2, so we know that the reciprocal of that 3x has to come out, okay? So if we're differentiating, we would take like a factor of 3 out, but because we're integrating, we're going to do the reciprocal of that. So it's going to be a 1 over 3 is going to come outside the brackets, okay? So 1 over 3, and then in brackets, we're going to have a 3x minus a 2. And now we're going to plus 1 to the power. So that would be a minus a half. And then we're going to divide by that power. So we're going to divide by minus a half, okay? And if we do that, what do we get? Well, the 1 over 3 divided by a minus a half, that's actually a minus 2 over 3. So we get a minus 2, 3x minus 2 to the power of a half, okay? And that would be over the 3, okay? And we know that we're going to have limits now of infinity and 1. So if we think about that, that would be like the limit as x, okay, as x tends to infinity of the minus 2 over, so I'm bringing the 3x minus 2 back to the bottom now, 3 times the 3x minus 2 to the power of a half, okay? Bringing it back to the bottom, and then that is minus the 1, right? Well, if we think about the 1, if I just draw it in for now, so we get a minus 2, and that would be a 3, and then that would be a 3, 1 minus 2 to the half. Think about what that would be down here, okay? So let's start with the limit as x tends to infinity. Well, as you can see, with the limit as x tends to infinity, what's going to happen to this? Well, if the denominator is, that's where the x value is, right? And our numerator is stuck at minus 2. So let's look at our denominator. As x, the value of x gets bigger and bigger and bigger, right? As that value gets bigger, it's going to be square rooted and then times by 3. Now, even if you square root and then times by 3, it's always going to still be a positive value, okay? Because when you square root, it's always going to, because obviously as x tends to infinity, the lowest value x can be is a value greater than 1, okay? X can never be a negative number, because remember, we are dealing with between 1 and infinity, okay? 1 and infinity, which means that x is always going to be a value between, well, it's going to be a value greater than 1, okay? So the smallest value of x is always going to be a positive number, always going to be greater than 1, which means that if you look at our x values, which we can get for infinity, all you do is think of positive values greater than 1. And if you think of positive values greater than 1, well, if you think of like 1 and then think of when x equal to 2, x equal to 3, the value of that denominator is going to get bigger and bigger and bigger each time, okay? If we get bigger each time, it effectively means that if I just give you examples, right? If we could have something like minus 2, let's say, over 11. Then as we keep getting bigger, the numerator is going to get bigger. So then let's say we have minus 125, for example. Minus 2 over 1,267, or minus 2 over, I don't know, 2,560. The point I'm trying to make is, as x gets bigger and bigger, our denominator is going to get smaller and smaller. I don't know. As our denominator gets bigger and bigger, the whole value of that is going to get smaller, right? Because it's a fraction, right? It's going to be minus 2 over that, which means that as x goes to infinity, it's going to tend towards 0. Therefore, all of this is just tending towards 0, okay? So therefore, that would just be 0. And for our other one now, we have this value over here. Well, that would just be minus 2, and then we get a minus 2 over a 3, and then that would be a 1 to the power of a half, which gives me a minus 2 over a 1 to the power of a half is a 1 over a 3. So therefore, we're left with, that is a minus 2 over 3, but then don't forget, we also have, it would actually be a 0 minus a minus, so therefore this becomes a positive 2 over 3. Therefore, our answer is just simply a 2 over 3. Okay, and for part B, we have a volume of revolution question, okay? We have that y is equal to a 1 over 3x minus 2 to the power of 3 over 2, okay? And it's between the lines of x equal to 1 and x equal to 2. And the shaded region is rotated through 360 degrees about the x-axis. We need to find the volume of revolution, okay? So how do we do these volume of revolution questions? So for this type of question, so I've gone on Desmos here and I've just kind of got the graph and I'm going to show you what kind of happens. As you can see, it's this is the line we've got in the question, okay? It's between 1 and 2. And for the volume of revolution, what are we doing when we rotate it 360 degrees around the x-axis? So as you can see, it's kind of doing this motion right now. What it's doing is it's taking the values. So imagine if we just had the area, right? It's taking that area and it's just rotating it 360 degrees. So if I just try and give you a better angle what's happening, as you can see, it is going across like this, okay? It is effectively going across like this, and it is now just making like a cone shape, okay? And we need to work out the volume of this shape it has now created, okay? So that is what we are doing. Now, luckily for us, it's given us a nice one, but because it's attached to the x-axis, it's actually okay to work out, and we have a formula we can use to work it out. There's another variant where it can give us more of a cylinder shape, and we have to work out the volume and then take away volume. But luckily, we've got a nice one where because it's attached to the x-axis and we want to work out and it's being rotated by the x-axis, we can just we have a formula we can use to work out the volume of this, okay? So yeah, now let's get on to working out what the volume of this revolution would be. So the formula for the volume of revolution when we have something like this is the interval of BA, okay, of pi y squared with respect to x, okay? So that is the formula. So in our case, what would that be? Well, that would be a v is equal to the interval of a 2, 1, okay, because we've got it between 1 and 2, and y squared, okay? So y, we know y is the 3x. Y is the 3x minus 2. And I'm going to write that to the power of minus 3 over 2, okay? And it's all of that squared, okay, with respect to x. So now let's go about working this out, okay? So if I just do that down here quickly, we get a v is the interval of 2, 1. And then, well, we're raising a power to a power, so that would just be 3x to the minus 2, and then that would be to the power of 3, okay? So now we managed to simplify that down. Now we can go about integrating this. Oh, I also forgot as well. Don't do what I did. Don't forget your pi, okay? This is all being multiplied by pi, okay? Remember, pi y squared, okay? So now we've got that v is equal to the interval of 2, 1 of pi 3x minus 2 to the power of 3 with respect to x. So now if I do that over here, okay? If we go about trying to integrate this, well, we can move that pi now outside, and then we can just integrate the 3x minus 2 to the power of 3. Okay, we can integrate that just by itself. So if we integrate this, we get v is equal to a pi, okay, and then that would be a, well, if we were to differentiate, right, that 3x, we take out a factor of 3, but then because we're integrating, it's the reciprocal, so we take out a factor of 1 over 3, and then in brackets we'd have 3x minus 2, and then we plus 1 to the power, so we get a minus 2, and then we divide by that new power, so we get a minus 2, and then we also have the limits of 2 and 1. So now v is equal to pi. Now 1 over 3 divided by a minus 2 is a minus 1 over 6, so therefore we can rewrite this as minus a 3x minus 2, okay, like that, to the power of minus 2 over a 6, and then that still has the limits of 2, 1, okay? And now I'm going to rewrite this as pi. I'm going to bring the 3x minus 2 down to the denominators. So we get a pi, and that's a minus 1 over a 6 lots of 3x minus 2 squared, okay? And now that's with our limits of 2 and 1, okay? And now let's just work what this is. So we get a v, and that will be equal to a pi. Then in brackets, well, if we think about a 2 now, if we put 2 in, we get a minus 1 over a 6 times a 3x minus 2. So what is a 3 times 2 minus 2? 3 times 2 minus 2, that's a 4. So we get a 6 times a 4 squared. So that's a 6 times a 16. So we get 1 over 96, okay? That's a minus 1 over 96. Then we'd have another minus, and then let's put 1 in. So we get a minus 1 over 6. And then we get a 3 times a 1, which is a 3, minus a 2. That's a 1 squared. So 6 times 1 squared is a 6 times 1. So we get a minus 1 over 6. Okay. So therefore, v is equal to a pi of minus 1 over 96 plus a 1 over 6. Okay. If you work that out, what is minus 1 over 96 plus a 1 over 6? That is a pi, and now in brackets you'd have a 5 over 32. Therefore, the answer to this question, our v, is going to be a 5 pi over a 32. Okay, last question. We've got the normal to the curve at the point 1, 1 crosses the y-axis at the point A. Find the y-coordinate of A, okay? So if it's normal to that curve, well, we know that curve, it was y is equal to 3x minus 2 to the power of minus 3 over 2. So we need to find the normal to that, okay? So how can we go about finding the normal? Well, what do we know? Well, we know that if we were to differentiate this, work out dy over dx, we put in the x value of 1 here because that's at the point we care about. We can work out the gradient of the curve, and then therefore we can work out the negative reciprocal, and that would be the normal to the curve. So let's look at the gradient of this curve first at the point y equals 1, x equal to 1. So we do dy over dx, okay? If we're to integrate this, a factor of 3 would come out, so it'd be 3 times the power of minus 3 over 2. So we get a minus 9 over 2, and then in brackets we would get a 3x minus 2, and then minus 1 to the power. So we get to the power of 5 over 2. Now let's put in our value now. We know x is equal to 1 because that's the value we want it at. So if we do that, our m value, or gradient, that would be a minus 9 over 2, 3 times a 1 minus a 2 to the power of minus 5 over 2. And therefore that gives us a minus 9 over 2. That'll be a 3 minus 2, so that's a 1 to the power of anything. So that is just a 1. So therefore we know that our m value is going to be a minus 9 over 2. Therefore, that's the normal gradient of the curve, but we want the normal to that at that point. So therefore the normal, let's call it our n value, that would just be the negative reciprocal, so that would be a positive 2 over 9. And then we also know our x value is a 1, our y value is a 1. Therefore, we can use the equation of a straight line now. So y take away y1 is equal to, in this case, n, in brackets, x take away x1. And now we can work out the equation of this line, okay? Or if by working out the equation of a line, we can then work out the y coordinate, okay? So therefore, we have y minus 1 is equal to a 2 over 9, x minus 1. Therefore, y minus 1 is equal to a 2 over 9x minus a 2 over 9. Therefore, we have y is equal to a 2 over 9x minus a 2 over 9, and then we're plussing 1, so we're going to, that would be a 9 over 9. Therefore, we have y is equal to a 2 over 9, and that's an x here, plus a 7 over 9. And therefore, if we worked out that the equation of a straight line is y is equal to 2 over 9x plus 7 over 9, we need the y coordinate of this. Well, the y coordinate would simply just be 7 over 9, okay? Because if we've got it in the form of like this, form of mx plus c, then the c is the y-intercept. Therefore, we know that it crosses the y-axis at this point here. Therefore, our y value must simply just be 7 over 9, okay? And that will be it for this exam. Only 10 questions, but this was definitely one of the harder papers, hence why there's only 10 questions. There's a lot of meaty questions here. But yeah, I would say there's anything too difficult. Some questions to really think about it, but and make sure you know how to do the volume of revolution questions as well, because those can come up as well. It's not a common question to come up all the time, but it can come up, so just be wary of that. But overall, it was an okay paper, but definitely one of the harder ones, I would say, hence was only 10 questions. But yeah, I hope you enjoy this. Next week, we will have November 2021, we'll have variant 2, so that'll be coming next week for you as well. So I hope you enjoyed this, and I will see you soon.